Advanced Algebra 2, Parent Functions and Transformations. I'm going to take you through the second half of the Concept 2 notes. So let's start by looking at horizontal and vertical translations. So horizontal translation, you're going to either add or subtract an h value to your equation. Vertical translations, you will add or subtract a k value. So if you look at the column with linear and down below, I have a basic linear parent function, and I have put where those other parameters, those numbers, can fall. So now with the horizontal translation, if we start with the function f of x equals x plus 2, and if we want to shift 2 to the left, we're going to end up adding 2, and we're going to do that right in by the x, because when we add, that shifts it to the left. And then we'll simplify. Simplified, our new function is g of x equals x plus 4, and that has shifted 2 to the left. Now for a vertical translation, we're either going to add or subtract a value at the end. So if we want to shift this 3 down, we will take our original function, which is x plus 2, and then we're going to subtract 3 in the k value location. So that's just at the end. So our final transformed equation will be x minus 1. Now let's transform absolute value functions. So if you look at the bottom of the absolute value column, I have that parent function and specifically where the a, h, and k values fall. So if we want to shift our absolute value function 2 to the right, I'm going to subtract 2 right in by our x. So we already have 3 added, so we are simply going to subtract 2. And then we'll simplify. So our simplified transform function will be the absolute value of x plus 1. Now, for this, we're going to, for our vertical translation 3 up, we're going to add 3 at the end. So we'll take our absolute value, and then at the end of what that equals, we'll simply add 3. And then that's just our final answer there. Now look at the quadratic column, and down at the bottom, notice I have placed the a, h, and k values and where they go specifically with a quadratic function. So to shift our quadratic f of x 3 to the left, I am going to add 3 just by the input. So I open up a parentheses, and I'm going to come back and add 3, and then the rest of the function just stays as it is. And so that will be our final transformation. Now shifting 4 down, I'm going to add 4 at the end of the function. Subtract. So we'll subtract 4. Now a 2 is already there, so we need to go ahead and subtract it from that existing value because we currently do have a k value. So our final function shifted 4 down from our one that we started, f of x will be x squared minus 2. Now we're going to look at reflections. So reflections in the y and the x-axis. So notice for a reflection in the y-axis, it's the input only that is made opposite. So in this case, in our equation form, it's the x's. So our first example, f of x equals x plus 2. We will simply make our input x negative, or multiplying it by negative 1. Now, a reflection across the x-axis, we're going to multiply the entire output by a negative sign to make it opposite. So here's my entire output, and then I'm going to multiply that by negative 1. So my transformed equation will be negative x minus 2. Look at the absolute value column. So to reflect in the y-axis, again, we are only going to make the input negative. So we're going to go right inside the absolute value function, and then the x that is there, we will multiply that by -1. So that'll become negative x plus 3. And I will check. All right, now for reflection in the x-axis, we are going to multiply by the entire output. And so our entire output is this absolute value. So we simply multiply by -1, which gives us negative absolute value of x plus 3. Now here's what it looks like for a quadratic function. So again, to reflect in the y-axis, we are going to multiply only the input on the right side of the equal sign. So that will be our x, and only the input by a -1. So that will become negative x. Now, funny enough, when we simplify it and square that negative, it is going to simplify to the same as the original. Sometimes that will happen and sometimes it won't. Now, for a reflection in the x-axis, we are going to multiply our entire output, which is x squared plus 2, by -1. So I'm going to show that by I'll just make it in red, -1. And then what you'll need to do is distribute that -1 to both of those terms. So it'll become negative x squared minus 2. Now let's talk about vertical stretches and compresses. So we're going to just focus on this one row. So the description is for a vertical stretch or compress, the entire output, what your function equals, is multiplied by the value, so by that stretch or compress factor. And if that value is greater than 1, it's a stretch. If the value is less than 1, it's a compress. So on our first example, with the linear function f of x equals x plus 2, we want to stretch the entire output by 2. So we're going to take the entire output of x plus 2 and we're going to multiply by a factor of 2, because that's what we're told. And then when we simplify, we're going to distribute that 2, so we'll get 2x plus 4. Now let's look at the absolute value function. So we're starting with f of x equals the absolute value of x plus 3. We want to compress that by half, so we're going to multiply the entire output. Now to do that, we are simply just going to multiply that 1/2 out front. We cannot distribute across an absolute value because it's an operator, not a grouping function. And so that will compress our function by a half. And then finally, look at that quadratic function. So we want to stretch it by 2. So we're going to multiply all of the output. So we've got 2 parts here, and we're multiplying it by, since we're stretching by a factor of 2, both of those. So our transformed function will look like, now the 2 will simply sit out front of our squared expression, and we need to distribute the 2 there, so it'll be minus 6. So that is a stretch by 2 with that quadratic function. Horizontal stretch and compresses are different than verticals, and that our position of our a value, where that parameter is multiplied, is different. So look at these 3 general functions that I have down below for linear, absolute value, and quadratic, and notice where the a value is. So now the multiplier, is right inside by the x, right inside the math of the function. And then on your notes, notice that I have here that when we go ahead and multiply, that multiplier a is the reciprocal of the factor that you are stretching or compressing by. So under linear, if we want to stretch it by 2, and this is a horizontal stretch by 2, we're going to end up multiplying just the input by a half. So not the b value at the end. So it'll simply be 1/2. And then with linears, once you have the equation written, and look at it, if you didn't do it yourself, you wouldn't know if it was a vertical or a horizontal because they look the same. Now, look at your absolute value function. So our original is f of x equals the absolute value of x plus 3. And we want to transform to have a compress or a shrink by a half. So our multiplier needs to be the reciprocal of that. So that's going to be 2. And that is going to go right in by the input. Does not affect the h value there. And so that is a horizontal compression by 2. I'm sorry, by a half using a multiplier of 2. And then finally, if we want to do a horizontal stretch by 3 to this quadratic, so just like the other two, we're going to need to go into the math of the function, right in by the input. So I'm just going to leave myself some space. And I'm going to multiply by the reciprocal because that's what we do with horizontal stretches and compresses. And so I'm going to multiply it by a third, knowing that that's going to give me a horizontal stretch by a factor of 3. One last note about horizontal stretches and compresses. So a horizontal stretch will stretch the graph toward the x-axis. A compress will take it away from the x-axis. They're difficult to kind of pick out when you're looking at a graph, but if you want to try, that's what you're looking for. Now in this last part, we're going to take equations and we're going to create transformed equations just by inserting either an a, h, or k value, or sometimes a combination of a couple of those into our equation. So our first one is we want a graph whose function is translated 3 units down of the one that you see before you. So if you think 3 units down, then that's our k value. So to transform a function that is 3 units down, we're going to subtract 3. That's our k value. So we'll do that just at the end of the function, and we'll end up with g of x equals 2x minus 2. And then with our b value, our b problem, we want to shift the graph 2 units to the left. So that means we're going to add 2 in the h position. So our transform function will be h of x equals x plus 2 quantity squared. Now let's try some reflections. So A, we want to create an x-axis reflection. And so we're creating a function g. So our new function will be g of x. And then we want to, for an x-axis reflection, the entire output needs to be reflected. So I'm going to multiply that entire output by -1. So our new function will be g of x equals negative, and it goes on the outside of the absolute value, -1. Now the next one, we want to write a function h whose graph is a reflection in the y-axis. So technically what we're doing is we're multiplying just the input by -1. But what happens with a linear, when we simplify, we end up combining that too, and so it ends up looking like an x-axis reflection. I'm going to jump to B with the vertical stretches and compresses. So we've got our original absolute value function, and we want to create a function h that is a vertical stretch. So I'm multiplying each part, so the first absolute value expression and the second, by a negative, and so that will change my sign. So I will get negative and I'm sorry, we need a vertical stretch. Sorry, by a factor of 2. I was thinking reflection. So vertical stretch by a factor of 2. So we're going to multiply both parts. And we'll multiply the -5. So that'll end up being -10. Alright, and then for D, we want a graph who is a vertical compression by a third. So each part of that absolute value function gets multiplied by a third, but since it's vertical, it goes on the outside of the absolute value, and then 1/3 times 3 is 1. Now let's go back and look at A. So we want to create an equation that's a horizontal compression of the graph by a factor of a third. And so our multiplier is going to go right inside the math of the equation by the input. So it'll be up, and we multiply by the reciprocal. Almost forgot. So it'll be 3x. And then we just finish the function. And that'll give us a horizontal compression or shrink. Now C, we want to write an equation that's a horizontal stretch by a factor of 2. So it's going to go right in by the x value, and we're actually going to multiply by the reciprocal. Now we do need to simplify that. So when we do, half of 4 is 2. So we'll end up with 2x plus 2. Sometimes we have multiple transformations to do, and so we just need to follow the order. So this says, let the graph of G be a translation 6 units down, followed by a reflection in the x-axis of that. So the first thing we need to do is just to introduce that k value, so that to shift it 6 units down. And then the second thing we need to do is to, for an x-axis reflection, we're going to create or make all of the output negative. So our absolute value becomes negative, as well as that k value at the end. It becomes the opposite sign. Now the last problem, we're going to try to describe the transformations in the order that they happen. So we're looking from this linear function to that one. So I can see, first of all, that my a value, and it's this number that functions as the slope, has gone from 8 to 8/9. So I have a multiplier, a factor of a 9th. So I can see that this is a vertical shrink by a 9th. Now you may be thinking, well, what about a horizontal stretch? So yes, I could also. We usually just, first of all, call it vertical if we can. But to be precise, this is also a horizontal stretch by a factor of 9. And then after that occurs, then we're going to have the graph will move 5 up. So a translation 5 up. Now if you look at B, going from the parent quadratic to this, we can see that we have this multiplier of A and then this k value. It's on the outside of the math of the function. So we could do that in order, and that would give us the transformed equation. So we'll have a vertical stretch by 2, and then a translation of 7 units down. All right, and that concludes the notes for our concept 2. And so now you can complete all the 2A and the 2B homework to practice those concepts.